Is the screen black? Yeah. Is the screen black for anyone else? It should not be black. Load the page in that case. I'm gonna make it my life mission to rewrite Tiger Beetle in row C if you don't give Halo Reach another chance. You're older and wiser now. Oh man. I never played Halo, but I did have an Xbox. If that makes it any better. I used to play on it. Oh man, I had a racing game. What was it called? Something like Midnight Racing. Midnight Club. Yeah, Midnight Club. Yeah. I had the original Midnight Club. I had Abe's Odyssey. Although it wasn't the greatest, to be honest. Wait, I don't know if no. It wasn't Abe's Odyssey. I think this was released afterwards. I had Manch's Odyssey, which was the first like 3D um Abe game. What else did I have on there? I remember I really liked also Ninja Gaiden, but I didn't remember if I was ever able to get it. I really do not remember. In any case, sorry, I was never just a fan of Halo, whatever. Um, in any case, you want to know how to port Tiger Beetle to C very quickly? You can compile the Zig code to C. Did you know that? So you can set your output format to C source code, and now you have Tiger Beetle written in C. Hello, CryptoCode. Also, hello, Andrew. I didn't greet you. Hello, Ace. Oh no, what did I miss? I'm so Firefox pilled now. I don't even look at Helvetica. Anyways, like who cares? Really? You're Firefox peeled? Just wait for it to like die because of an infinite loop in JavaScript or some other silly thing that should work that just does not work on Firefox. You'll get there. There's so many nasty grumpy accuser. Look, there are so many reasons to hate Firefox. I don't know, man. I just can't. I still use it, by the way. On my main machine, I still use Firefox. So it's not like I just made up my mind and I decided that now I hate it. I use it daily. And it mostly works, just mostly, though. Not entirely. I also need to upgrade macOS. Not looking forward to that. Yeah. Hello, Rohan. I think you were using Linux earlier. I mean, I have a Linux machine here, yes, but I don't know. I don't use it much for browsing. I mostly browse from my main computer. Sorry, from, I mean, it's the same computer, but from the host operating system. Is incremental in the Linux VM faster than LVM debug on macOS? You know, I'm not sure because I have not tried incremental yet on Linux because it needed Arch. So that landed very recently and it's not complete yet. It's also not turned on by default. So I literally have not tried yet. But I suspect probably yes. I mean, yeah, this, okay, so you're asking, wait, not incremental, this self-hosted debug backend. I might be wrong, but I think that that incremental works on Linux ARM within the limits of what the backend can do. So I think that if the backend doesn't have problems, you know, doing code gen for a given Zig program, then I think that incremental works. But I haven't tried it yet, so I'm not sure. Maybe I should. Maybe I should. Let's see what are people saying. Oh, there was this one that I found interesting. So this recently got posted on Lobsters and also Hacker News. Where is it? Yeah, this Python stuff. Super functions solve the color problem in Python. And now super functions is called trans functions. So apparently they're, I don't know, they renamed the project at some point or something. And then that's how they solve it. Is there an ultimate end goal Zig has towards safety for 1.0? I'm talking about memory and async safety. No. Or rather, yes. Sorry. No, maybe no in the sense that, you know, people would want as in like safer than Rust. No, not safer than Rust. Not in the same way, at least. But there are some goals in that regard before 1.0, specifically making as much as possible of illegal behavior detectable at runtime. So let me give you an example. You have in Zig, overflow, integer overflow is undefined behavior. Well, sorry, I should say illegal behavior. Because saying undefined behavior means, kind of implies that you're pulling in the exact definition that C uses, while it's not the exact same in Zig. So let's just call it illegal behavior. That has been the policy for a while. So, but the point is, you're not supposed to overflow integers in Zig. That is considered wrong unless you request it explicitly. So if you request explicitly overflowing, as in let's say wrapping, then you get wrapping, and that's usually the default behavior on most platforms. So all is good, but you're requesting that explicitly with an operator. You're using like wrapping addition plus percentage and other similar operators. If you don't use the percentage, then if you overflow, that is considered a programming error in your code. Now, this type of stuff is detected at runtime. It is detectable at runtime. If you run a debug build or a release safe build and you overflow an integer, you get an immediate panic. You do not get the wraparound. You do not get the implicit platform specific behavior, which usually is wraparound. You don't get that. You get a crash, like a well-behaved crash, a panic. So sorry, I should say maybe a guaranteed crash, a panic. But not every single programming error can be turned into a guaranteed crash. So for example, right now, if you return a pointer from a function frame, so you return a pointer from local memory, that is allowed, that will happen, and Zig will not turn that. If you try to access the pointer, then Zig will not turn that into a panic. If you use Valgrind, like if you run the application through Valgrind will report that that's a programming error, but Zig itself does not. The idea, the plan for 1.0 is to work hard to make as many of these programming errors guaranteed to become a panic immediately once you run your program. How many of those is realistic to be able to turn into panics, and what are the limits of panicking? Because probably you can catch, I suspect that the reality is that you can probably catch a ton of these things, but maybe not exactly all of them. So there might be some holes that you just cannot fill depending on what the programmer wants to do. But this has not been fully explored yet. And once it will be fully explored, we'll know precisely what can be done, what cannot be done. What are the limits of what we can guarantee? Maybe we can guarantee that if you return a pointer from stack memory, it works. But then we decide that we conclude that we cannot guarantee that property if you take the pointer, turn it into a number, and then store it somewhere as a number, and then you turn it back into a pointer afterwards, and then you access it afterwards. Or maybe it will be possible. Actually, I would say that it's not entirely impossible that we could track that. So, but this work has not happened yet. And so when that happens, we'll know exactly. So I know that won't be the same memory safety as Rust, but I'm talking about like the most common things like returning a pointer. Yeah, okay, so that I mentioned. There's also other ones that could be added. As for like async, the idea is to have a test IO implementation that can be used in combination with fuzzing. I don't know if we will need fuzzing necessarily, although it probably will. So let's assume that the IO implementation, actually, you know what? Let me take a step back. For allocators, there is a testing allocator, not the testing allocator, but there's another allocator. It's called, I think, failing allocator, where basically you can tell that allocator to fail a specific allocation. And so you can run a test in a loop where you basically take that allocator, and every time you run the test, it like the first time fails the first allocation. Second time, the first one succeeds, the second one fails. Third time that you run the test, first, second allocation succeed, third one is the one that fails. You get the idea, right? So you basically iterate over this, and you test that every single allocation failure is handled as expected, and you don't get unwanted behavior. It's not exactly memory safety, right? Because failed allocation will return an error, but it's more about, did you actually program correctly what should happen in that case? Is gonna happen what's gonna happen when that failure happens is what you want, or is gonna be some other maybe less graceful early exit. Now for IO, and so async, we can have a testing IO implementation that does something similar, not exactly necessarily failing to do stuff, although it can fail to run stuff concurrently, because we make a distinction between asynchrony and concurrency. So calls to io.async will always succeed, but calls to io.concurrent might fail. So we can have that fail. So, like the first time you call it succeeds, then you do it again. The first time you call it fails, then you do it again, and then the first time will succeed, the second time will fail. So that we can do like linearly. But there's still the problem of, okay, you launch like two things in using async and one using concurrent. And so this could be executed in different orders. And I think that the total combination of possible orders might be, a combinatorial explosion. And so either the IO implementation is able to understand like barriers and the synchronization barriers of some kind, like it can basically simplify and avoid useless tests, or if it can't, which I would consider the null hypothesis, then you use a fuzzing approach where each fuzzing run has like a seed, and you use that seed to basically have one specific run of your test, and then basically use that to try a few different combinations. Does that catch everything? That alone, as I described it, no, it will not catch everything, but it will catch a lot of stuff. And so then, what's missing maybe can be caught in some other system. For example, there's also the idea that, when you're running your tests, this can also be run in combination with thread sanitizer. So the test turns on thread sanitizer, and now you also, get thread sanitizer reports at the same time, even if you didn't implement it yourself. Or maybe there is something to gain by implementing this stuff ourselves. I don't know. So you're in a strictly single-threaded or single-core environment, you will have to patch the package yourself, or when there's usage of async concurrent in the package. No, when there's usage of async concurrent in the package, it means that your package just cannot run on a single-threaded. Okay, you know what? Let me take a step back, because I feel like there's a little bit of confusion in how you're describing things. Don't worry, this is. Everybody's confused about this stuff. I feel like we got lucky because we went through this analysis to design this stuff, and that has given us a very privileged perspective on this. Not that we understand everything, of course, but there's a lot of confusion. So if you have a single core machine, that means literally nothing. The fact that you have a single core is not a problem, because a single core, cores are a unit of parallelism, they're not a unit of concurrency. Your OS will be able to multiplex multiple threads on a single core. So from the software perspective, other than performance, single core, multi-core makes close to no difference. Then, if you say single-threaded, then yes, actually, at that point, it doesn't matter how many cores you have. If you only have one single thread, then you don't have threads as a unit of concurrency because you only have one. That said, even when you have a single thread, you can still have concurrency, but that concurrency will not be provided by the OS. It will be something that you implement yourself in userland. That would be green threads or coroutines, stackless coroutines. Green threads are not OS threads. They're like stacks that you allocate in memory, and then on the userland side, you jump from executing one stack to the other. You swap the stack that a OS thread is currently executing, and so you jump from executing one function to the other. So you can do that, but client, like say userland concurrency requires the usage of non-blocking OS IO APIs, and also for synchronization as well. So you need to be able to not block. So you cannot do a blocking read, you cannot do a blocking write. You need to use a non-blocking API, and same with synchronization, like locks. Basically, you can't just use a normal futex, for example, because the futex will block you there and then you die. So because you can't task switch, because again, the assumption is it's a single-threaded. So I'm going to be more precise with what I think you were asking. What do you do if you are in an environment where you have no concurrency? So you don't have multi-threading, so you have single-threaded, and you don't have userland concurrency. So you don't have green threads, and you don't have stackless coroutines. So you're doing single-threaded blocking IO, basically. When you are doing single-threaded blocking IO, will you have to patch a package that uses IO concurrent? The answer is no, you will not, because you will not be able to run that package. If a package uses async concurrent, it means that that package needs concurrency to function correctly. It means that it's impossible for that package to run. The reality, though, is that will not be often the case. I would say that it will be almost always the case that your package that you use will not have any. We're renaming async concurrent to just concurrent, so we will not have any IO.concurrent call, and probably will not even have any call to IO.async. It might, but at that point, it doesn't matter to you, because when you see async calls, then you know that you can run them also one after the other, and everything will work fine. But concurrent means that concurrency is needed, and so you can't just patch the thing. It means that that piece of functionality just cannot function without any form of concurrency. Yeah. And these definitions that we're using are not the definitions that everybody uses. And it's not just to be, special, but it's because we need to make a distinction between asynchrony and concurrency. And other ecosystems they don't care about making that distinction, so they tend to conflate the two concepts into one. Parallelism is stuff at the physical level running simultaneously. So you have 3 cores. Those 3 cores will do work at the same physical time, like t equals 0, something is happening on all 3. T equals 1, all 3 will have made some progress potentially. Threads are not that. So CPU cores give you that, but threads are not that, because threads can also be task switched on a single core. Like a single core computer can do networking, can do, you can do multiple things at once. Like you can play a movie and move your mouse cursor on a single core computer, because the single core computer will be able to just compute one thing at a time, not more than that, but it can keep switching from one thing to the other, and it can switch fast enough that you will be able to still watch the movie and move your mouse at the same time. So threads are a unit of concurrency, and concurrency means juggling multiple things at once, which through task switching. And task switching from threads is implemented by the OS in a preemptive manner. So the OS schedules a thread on a core, and then the OS automatically takes that thread away. More specifically, it's the CPU. The CPU has a concept of evaluation, like running quotas. So it basically, roughly speaking, runs, 3,000 instructions from a thread, and then jumps back into the kernel. And then the kernel decides if that thread should run for another 3,000 instructions, or if it should instead be switched with another thread. And stackless coroutines and green threads are the same concept, except they're not managed by the OS. They're managed by the program itself. And then it's the program that does the scheduling. And they can do that scheduling off of one OS thread or off of multiple OS threads. Physical cores are split into 2 logical cores for the most part. Don't forget that. That is not important. Like, that is absolutely not important for the purpose of the discussion. The 2 logical cores is just, I believe that it's just some memory that is like some extra memory, so that it can so it can switch faster between threads, which is probably good to have, but it functionally doesn't change anything in our explanation. So now memory is 2 streams that work at once. Okay, sounds good. Let's see. Thanks for the explanation. I'm not very well read on how async and await actually works. Yeah, no worries. Concurrency is complicated. It's absolutely non-trivial to get used to, and yeah, it's not obvious. And also, if you learn async await from implementations that languages offer you, then you will also learn their quirks. Like, for example, there's a ton of people that use async await in JavaScript, Python, I think also Rust, and they're used to this concept that any form of async, any form of async as in asynchronous execution, implies that you need to put you need to spread the async keyword everywhere, and you have to use await everywhere. And that's one specific model. So if by async you mean the specific keyword used in, say, Rust, and how that relates to also usage of await still in Rust and how everything is implemented, then some of that has to happen in that context. Same with Python also. Although Python and Rust internally have async that works in very different ways. Absolutely, they're not at all similar implementation at the implementation level, I believe. So, yeah, there's like this soup of concepts, and people keep jumping left and right between them, and I feel like that none of them is really what you need. You need these, like what I try to explain in the blog post. You need a slightly more abstract understanding of the basics, and then off of that you can evaluate how a given implementation works, at least to some degree. I understand also that if you're not into like compilers and stuff, it's not immediately obvious. Like if somebody tells you, oh yeah, like a coroutine makes a state, the compiler transforms these things in a state machine. What does that even mean? It used to be worse. People used to say Oh yeah, it basically turns your thing into a continuation, and then basically async and await is a way of doing continuation passing style, but without the passing style. And which is not a great description, I would say, but that's something that I heard in the past. Maybe you know why Zigland org docs doesn't work, does it? Works for me. What do you think about this tweet? Ziglang has abstracted into a unified interface the high-level async, e.g. Elixir's task on async/await, with how using await works in lower-level languages, and lets you, the user, pick and choose with one line of code. I am not familiar with implications. I'm not entirely familiar with the implication of making a parallel with Elixir because I don't know precisely how Elixir works. Although maybe people in chat who use what's it called, like the Erlang VM can confirm or deny. But I believe that that VM uses green threads. So basically, I guess my point is that you're comparing one specific implementation, and maybe that comparison helps people understand a little bit. But be careful because also it has a downside that usually these implementations imply things that we don't imply. Let me give you an example. If in Elixir, every time you do, you know what? The fact that this is a task, that already smells fishy. The fact that async implies that you're scheduling something on a coroutine, that's already not what Zig does. Explicitly, not just as a implementation detail, but like that alone is maybe the biggest point of our async design. Because if you call async, Zig is allowed to run the function immediately as a function call. No tasks, no coroutines, no state machines, no continuation passing, no callbacks, none of that. Immediately calling the function, like literally, your function parentheses your arguments right away. So new function frame on the stack, run it, get the result, save the result into the return value right away. We can do that because we have this formal system in place where we say that you use async. Async alone does not give you a unit of concurrency. It doesn't imply giving you a unit of concurrency. So this is a big deal. And yeah, I don't know how to explain this other than, directly saying this concept, because usually it never works this way. Completely unrelated to async, has anybody done gRPC in Zig? I believe so. I think somebody has. And I think there are gRPC libraries in Zig. Maybe not that many, but I think a few are out there. I cannot tell you, though, how good or not good they are. What are your thoughts on thread per core architecture and IO ORing versus the current thread pool and impl implementations? I think that's roughly how we want the green thread implementation to work. Versus the current thread pool and impl implementations. I'm not sure also what you mean by the current thread pool and impl implementations. What are these current implementations? Are you talking about Zig? Because so maybe you're referring to something specific that I'm not realizing. But if you're talking about the new IO stuff, we have a thread pool implementation. We have two implementations right now. A thread pool implementation that does blocking IO. So, it's like 10 threads. They run stuff and they do blocking IO. So they do, a normal print and then the thread blocks. But we have multiple threads. Or second, it's green threads. And green threads uses IO ORing, and I believe it's definitely one thread per core. Although I believe that right now the current implementation doesn't do fancy stuff like pinning a thread to a specific core. I'm sure there's a ton of clever things that you could do that currently are just not implemented. The beam, right? The beam, I forgot. Uses something similar to green threads, but they share zero state, so they're like green processes instead. Right, that makes sense because Okay, I get it. Like at the usage level, you don't usually have the ability to share uh to share memory, and so they do communication mostly. I guess my point is, given that they exist within the same process, that they can access each other's memory, but I guess they normally don't do that. And if I remember correctly, it's also because the beam wants to be able to ship a process to another like machine over the network, something like that. So yeah, I get it. Okay, makes sense. I use Elixir in my day job. You don't have much control over how the Erlang VM schedule things. I think they are different. No, well, the fact that you don't have control doesn't mean that that it uses a specific implementation. And I believe that specific implementation is green threads, as Blurrycat was saying. Let's see. Classic simple implementation of concurrency in C is just callbacks where you store the variables in heap objects. Central issue is to store the state somewhere that the language compiler can help with that. What has been the reaction from the larger project community using bun, ghosting, etc.? Wait, I'm missing something. What was the reaction about what? About the async stuff? You mean from like larger projects using Zig, bun, ghosty? So you're saying like bun and ghosty? Like the question is, what do the bun people and what do the ghosty people think about these changes? Is that the question? I'm not sure. I'm not sure. I think Mitchell maybe said something about it, although I don't remember anything specifically, but I think he should be generally on board because Ghosty uses this right now. It uses libxev, and that's a IO ring event loop basically, and epoll for fallback, KQ on macOS, and so honestly, I'm not sure what Mitchell will want to do with libxev once Zig starts bundling an event loop internally. I don't know what he will want to do, but I think it would not be a bad idea maybe to all converge towards the standard library implementation. Although it is absolutely not a necessity, because the fact that IO is an interface means that you can bring whatever implementation you want. It's part of the design. So it's not like the existence of other alternative event loops is like third-party event loops is a problem for the ecosystem. Not at all. It's part of what should happen. That said, if I remember correctly, I don't think that libxev is doing anything significantly different than what I think we'll have in the standard library. So I don't think we'll have a reason to really. I don't see a reason for divergence, I believe. And libxev is also not fully complete yet. So there's a bunch of work that Mitchell would need to do to complete this project, which he could not do if he doesn't have a reason to. That said, you know what? I may be totally wrong. Maybe there is something that Mitchell would gain from keep using libxev. At the very even just from the perspective of keep using your own code as much as you can. And so maybe he will continue to maintain it. I don't know. As for Ban, I don't really know anything about how Ban sees these changes, because Ban is a much more complicated project. It has to integrate with a huge number of C++, I think mainly C++ stuff, and I'm not sure exactly where these changes would benefit Ban. They should benefit Ban to some degree, because now they don't have any more generic readers and writers, and I think that's good for Ban because it helps reduce code duplication. It helps reduce code bloat, sorry. And especially in a large project. Like in large projects, it's easy to have duplicated stuff in there by mistake, or even maybe not strictly by mistake, but even just because of like how it's architected. And I think that the non-generic readers and writers will help with that. The new reader and writer API is better. It's just good. So I think they might get some enjoyment, like some small improvements out of that. But that's mostly it. As for the rest of the IO stuff, I don't know. I don't know because like should Bun start using async in the code? I really am not sure. I think no. I think that probably it would make more sense for Bun to assume a specific configuration like multi-threading with their managed thread pool implementation or whatever. I don't know. So I don't know. Okay, let's get some work happening. So let's do. So here's what I want to do. I want to make a PR to the Zig build system to add a little bit of behavior. And then there's some minor changes that we want to do to code owners auto merge that I worked on yesterday. This is a new GitHub action that I made in JavaScript. Lots of fun. I love writing JavaScript. And it works. There's just people have suggested some changes that make total sense. So I'm gonna implement those. Then what else? There's some more bugs in Zen that probably need to be looked at. And then my last idea was not to do today, but as a idea for this weekend. This weekend I'm gonna be particularly free to live stream if I want to. And so I was thinking maybe it's a good weekend to do ray tracer in a weekend. So sorry, it's not ray tracer, it's ray tracing, right? Ray tracing in a weekend. So maybe we should do ray tracing in a weekend. And you know, once the weekend comes. So you know, at the appropriate time, basically. I cannot believe that people do ray tracing sometimes during their week. That's just disgusting. I don't know. So yeah, we can do that. But I'm not sure. I'm just leaving it there. Maybe I'm gonna mention it near the end of the stream. Okay, if anybody has any other async questions, feel free to ask. I think I'm gonna just go get something to drink real quick, and then return and start the work. Also, I need to write, I think, a reply on the website repository. So ziglang.org. I think I told Amlag that I would reply to this one. Oh no, he did. Okay, so I don't have to do this. Okay. I'll be right back. Okay, I'm back. What are the main places where the Z compiler development discussion happens? GitHub, of course, first place. Second place, there's a Z Software Foundation Zulip server. It's listed in the communities page. These are pretty much the only two places where compiler development discussion happens. Okay, so we don't need to do this. So we can get to this immediately. Also, I'm curious, did Matt merge the other build system change? Yeah. I'm gonna ask him. So, by the way, Matt did this. So we had a discussion about the utility of strip, and he made a point that strip is not really is mildly useful, maybe for, let's say, newcomers. Like a super newcomer doesn't want strip; they want the comments. They want to learn from the comments. Then after a while, let's say that you read this stuff, I don't know, like 5 times. You hopefully started to internalize it, so you don't need the comments anymore. So you could do -s to strip the comments, but then you still get a like pretty beefy like init. Um, and so he made the point that well, this doesn't really help him, or like him as a example of somebody who is not a newcomer, who maybe would appreciate a little bit of boilerplate, but not a ton. And in his case specifically, like him, it's annoying to do a zone file on your own because you have the fingerprint to figure out. So if the zig anything gives you the zone file, that's like 90% of the of the solution basically. And so he made it so that instead of -s, we have -minimal. So the idea is let's not have a ton of flags. Let's just have one. So we're gonna replace that one with this one, and this one gives you a project that only has a zone file and a build script. And the build script only contains the signature of the build function, nothing inside. So apparently a bunch of people like it. Okay. Um, so yeah, so I was asking him if he wanted to just pull the trigger and merge it. Okay, in the meantime, I'm gonna make another PR though. So what we're gonna do here is I guess git pull first and foremost. Then we want to git switch. No, we want to git checkout. Actually, what is the new branch command that doesn't go through checkout? I'm assuming there is one. I just don't know. Build always. But you can do. But can you do git switch to make and also use it to also make a new branch? I mean, it wouldn't be surprising if you could. It wouldn't be surprising, sorry, if you could. But I never used it that way. You know what? Maybe this is the time. Git switch -h. Let's see what it says. -c create branch. Create and switch to a new branch. Yeah, but in my case, I just want to create a new one. Yeah, what if I do? Okay, let me try this. Git switch build always print fatal invalid reference. Okay, so I do -c. Switch C requires a value. What? Oh, the branch becomes an argument of -c. That's a choice. That's certainly a choice. Okay. So instead of git checkout -b, now it's git switch -c. Do you want to create a branch without checking it out? Wouldn't that be under? No. I also want to switch to it. Git checkout -b makes a new branch and checks it out. So I did want that, but I never used this, specifically this. Okay. But also laughable that it doesn't accept this syntax. Like that. Honestly, I find this absolute cringe. Anyway. Okay, so build always print. What we want to change is in run. So here's the problem. Okay, here's the use case. I'm actually experiencing this. Like I'm proposing this change because I'm experiencing this. So in github.com Christoph IT Zen, I have a failing CI. And here's the problem. CI has been failing for a while. Sometimes it's because of nicks. So the nicks stuff is build timeline, the terminate nicks build summer. What the fuck? Okay, holy shit. What? Okay, sorry, I didn't know that the nicks stuff was so fancy. Sometimes it's the nicks stuff, but the nicks stuff is not important right now. What's important is that I have an actual snapshot test failure on Linux, and I can't reproduce locally. If I run these tests on my local machine, they work correctly. They succeed. So I don't know what's happening. I don't know what's going wrong. And the idea is that what's failing is not just like the snapshot test. So it's not failing the comparison between the outputs. It's failing the execution. Like I'm running Zen release, and that returns a non-zero exit code, and that's what's making everything fail. What is the problem though? The problem is that here we should be seeing an error message. We should be seeing what went wrong, but we don't see anything. So, so my question is, well, why am I not seeing anything? Why can't I see the error message? And the answer is I'm not seeing the error message because I'm capturing it in my build script. So I can maybe show this in another tab. In my build script, in snapshot testing, when I run the executable, let me find this one. Okay, this is the invocation. We're looking at release force output snapshot. Zen release force output snapshot. When I run this, I captured standard error because I want to write it to a file. The problem is this fails to run, and so any operation, downstream from this build task, build step, will not run. So we're basically capturing standard error, and then we are writing it to a file, but we're not doing this. We're not doing this because this operation failed. So everything downstream of it will fail. There are ways to change a step so that basically you expect failure of the executable. So you can do that. But in our case, we don't want to do that. That is generally a failure. The problem is because we're capturing standard error, we don't see it printed in the terminal. And normally, if we were not capturing standard error, here we would see the error message. Now, actually, that reminds me, you know what? Technically, what I could do is comment out the error capturing message, make maybe APR to Zen, and have these tests run on a branch. And in that branch, I would be able to see the error message. But you see how that's annoying. Like so I could circumvent this problem now that I think about it. I didn't realize this yesterday, but this is circumventable if I want to. The problem is it's annoying behavior. So how do we avoid this? The answer is, in my mind, since normally running an executable shows you standard output and standard error, but it doesn't when you capture it, then what I would do is if the command execution fails, this gives you a run step. If the run step fails and we are capturing standard error and standard output, we print it anyway, as if you weren't capturing it. With the, let's say, so we could imagine as if that capturing standard error is like a separate step that happens afterwards. That's not really true. It's not how it works. But basically that way, you don't lose standard error and standard output if you try to capture it. It still gets displayed here. So that's it, yeah. And you know what I'm going to do maybe? I think I'm going to make a PR for Zig with this change. And then I'm in any case going to unblock myself doing the PR thing that I mentioned earlier. So this way we can diagnose what the heck is going on with Zen and fix that. So here's how it works then. In the build system, the every build step has a configure and a make phase. Configure doesn't even have like a create function. Okay, so it doesn't have like configure as an explicit function, it has create. But in any case, first you create the step and you define what should happen when it runs. And then make is when it actually gets run. So in the make step, this is where we are basically really, for real, building the CLI arguments, etc. And then we are go down, go down, go down. There we go. Here we are running the actual command. Is it always here that we run it? Let me see. No, this is in case that there's a dep output file. There's, I think, another invocation to call to run command at some point. There we go. This is the other one. This is the non-dep file version. So here we run the command, and then here we do the downstream execution where we worry about where is it? Has side effects, rename any output. Return in fast mode, populate path. Wait a second. Run command. Okay, so in run command is where we have the thing that I care about. Let me see. Run command. There we go. Here, this is the trying to capture standard error, and standard output handling code. I think you would include it in a step.fail message. You mean the standard error, standard output? I don't think so. I think I would just print it. Because if you think about it, when you're not capturing standard error and standard output, what's literally happening is that those prints reach your terminal without any other ceremony around it. So that's what I was thinking of basically replicating. It's not going to be an exact same thing because we're going to lose the, intertwined, because normally you would see maybe some prints to standard out and some prints to standard error, depending on how things happen in the executable. In our case, we're going to see all standard output and then all standard error afterwards, or, whatever order I decide to do it. But setting aside that difference, I think it should be basically the same. Just so, let me show you. That said, I don't know. This is the implementation that I'm thinking of. Maybe there are reasons to do it differently, but for now, I don't see it. Can you share what's the benefit of shifting error messages to runtime for the upcoming changes to Zig? Of shifting error messages to runtime? Vincent, I don't know what you're referring to. Sorry. Can you be more specific? I think you're generally not supposed to write directly to standard out, standard error inside the build system, so it can coordinate output. Let me think about it for a moment. No, I think the way this is that when you have an executable that is invoked by the build system, that supports the build system communication protocol, then you don't want to spam. I don't remember which one of the two, maybe standard out. You don't want to spam it because that stream is used for communication. But I believe that this does not apply to the build runner itself. My understanding is that the make step is executed by the build system itself. And the build system itself has its own standard out wired to your terminal normally. Also, let me put it another way. As I mentioned earlier, if I wasn't capturing standard out from this process execution, we would be seeing the message down here. We would be seeing down here standard error. That's what happens normally. So that already happens that way. And I believe it happens, quote unquote, naturally because of the fact that we're just not capturing standard error and standard output. It happens transparently just because the child process inherits standard error and standard output. This is my understanding. See what the run step does with standard out, standard error. Well, when you capture it, it saves it. When you're capturing, it takes the captured std out, which is a string, and you capture stdr, which is another string. No, wait a second. This one, which is this result std io stdr, and these are just strings. And then it just writes them to a file depending on what you're trying to do. But I guess the point is, what if you're not capturing? Okay, so let's go up and see what happens when you're not capturing. Let's see, run command. Spawn child and collect. Let's see. Oh man, there's a lot of code about the dealing with trying to run in various environments. Step handle verbose to spawn child and collect. Let's see. Has side effects pro node to unable to spawn interpreter. If I'm right, there won't be a way to not capture. So you're saying that it captures unconditionally. No, it should not be. Although, you know what? Result.stdio. Okay, go to definition. Where's the result? So here, result gives us this. Let's see. Spawn channel collect. std in behavior. Let's see. Infer from arguments. If has side effect, inherit. Otherwise, ignore. Inherit, check, ignore, sig test, pipe. So it does have an inherit option. Yeah. So it's not doing manual printing normally. It's just naturally inheriting the stream. That's how I understand it. Okay, so what's my idea then? That in okay, here we're looking at the streams. Stream is captured. Okay, wait a second. I'm starting to lose track of what I'm doing. Spawn child and collect. Here in spawn child and collect, where are we checking if we were trying to capture? I guess run contains information whether we're trying to capture stuff, right? And it's based on these guys. Okay, so it's based on these guys. And here we also have the result, which is what we return. So wait a second, go to references. So here we put everything in result, which goes after all this crap. Here we deal with the stream. here we deal with the fact that if it was a check, expected match, expected term, zig test, and then we do try handle child process term. Okay. And here we look at term and we decide if it should be something that we decide if it failed or not. And if it failed, what to print. You'll get a compilation failure, but it will still produce a binary that you can run. Oh, that part. Okay, so now I remember. And then when you hit a function that has even a syntax error, it will just print a runtime like syntax error in that function. Yeah, so so this is an idea that, as far as I know, has originated from Rock. Yes. I don't know if anybody attempted this approach before. I guess to some degree you kind of get similar properties by default when you're using interpreted languages and the interpreter is just interpreting stuff on the fly. But obviously, how can I say, designing it is different than just having a similar property that just happens to fall on your lap because of how things work. So similar, but not exactly the same. And so, yeah, as far as I know, Rock is the first language that is attempting this deliberately. I might be wrong. There might be a longer history behind this stuff that I just don't know about. And so, yeah, the idea is that basically Richard talked to Andrew about this, and Andrew was intrigued by the idea. And so, yeah, so the point is, there's you will get a compilation failure. So the idea is you will get a compilation failure, but then if you really want, you can still run the binary and see what happens. I don't know how. So I think that Andrew finds the idea generally interesting and wants to attempt it. I don't think he has designed, the whole set of interactions start to finish. So I would say it's something that he wants to explore. It's not guaranteed to become a thing. Maybe he does it a little bit and figures out that it doesn't do what he wants, or maybe he will, and it will become a big feature of Zig. So that's it. What was your original question? Let's see. Can you share what's the benefit of shifting error messages to runtime? So yeah, so what's the benefits of doing that? Yeah, the benefits is that basically with this in place, then a certain compile errors are not a blocker to trying out the functionality. Let's say that you are doing a big refactoring, and there is a specific code path that you want to update in a certain way, and that causes some type mismatches in other functions that normally result in compile errors that prevent you from being able to compile. If you introduce this system, then you will still get a compile error, but you will also get the output file. And as long as you only try to run the happy path that you created, right, the path where you fixed everything, then you will still be able to run that one. And so you see how it goes. And if you like what you're seeing, then you can commit to updating the rest of the executable, the rest of the source code, because otherwise you wouldn't even be able to run your experiment once before updating everything else. Another example is unused variables. In Zig, unused variables are a compile error, but also it's a type of compile error that doesn't really prevent your application from running successfully. And so that's why people would like for those errors to become warnings, but Zig doesn't have a concept of warnings. So the idea is that with the system in place, you could say, yes, unused variable errors stay errors. They still prevent you from compiling successfully. But while you're, let's say, doing exploratory work, you can still run the executable. But I guess it depends on how you design unused variable errors, because if you decide that unused variable errors do not become crashes at runtime, then it works. If you still decide that they should become panics at runtime when you hit that line, conceptually speaking, then you will not get much benefit actually. So it depends on how you design this stuff, right? There's a bunch of like design decisions that you have to make on how you want things to map and like translate to in this system. So I don't know. I do think here's my suspicion. My suspicion is that this approach is probably better suited for Rust. For Rock. I keep saying Rust. Sorry. I think this approach is probably better suited for Rock than Zig, but I may be wrong. It's just a hunch. It's not a strong certainty. It has been thought about maybe having it build normally with errors in debug, but on release and at runtime, it's panic. I think this system of compiling even in the presence of build errors is building even in the presence of compile errors is just an idea. There has been absolutely zero concrete work on it so far, so it's too early. So have it build normally in debug. So you're saying if you're making a debug build, then it will not panic. But if you're making a release build, that gets lowered into a panic. That seems a potentially clever approach. Yeah, that makes sense. Mm-hmm. By the way, if you just have ZLS with autofix enabled, you know that this is a non-issue because ZLS will toggle this stuff for you automatically. Just saying. I don't love it, so I keep it disabled. But that's a thing that you can fix today. You don't even need this novel way of approaching compilation failure in the compiler. Just leverage ZLS. So what is eval child process? Oh, it's public. Eval child process. What the fuck? Returns std out. What even is this function? And it's not used anywhere. Nobody is referencing this. What even is this? Nowhere in the code base. Public, but also weird. Evolve child process. You give it a step, you give it some arguments, and it returns you either an error or its standard out. What? Capture child process. Capture child process is only run by eval child process. Handle child program unsupported. Handle verbose. Fail to run. Who's using this stuff? Capture child process. FMT is using this. FMT runs capture child process. Okay. I guess maybe we can remove this. In case, let's go back to our main thing. Okay, so make build step. No, I want to run. Okay, when we run make, we end up calling into run child, where is it? Run command. Once here, in the case that we have a manifest file, sorry, that you have a dep output file. This is one case. In the other case is, well, down below, but also run command is something that just returns an error and it doesn't return anything. So it doesn't return any output. So if we do any change, if we make any change, it needs to go inside run command. So at least either run command or deeper. So in here we have a call to spawn child and collect, and this returns a result which has the how it ends everything and the stdio stuff, in case it's captured. So I would just do it this way. If it fails, we just print it if it's captured. Although I guess not, that's not entirely it. Let's see. And this is run twice, once in there and once in here. Is this inside the outer call? Yeah, so this is the inside the outer call. So that means the result in the end will contain what we want no matter what. Okay, so here, there we go. Step, test results, stdio test results. Oops. Fail count, skip count, test metadata. Final argv. String capturing. So what I would do maybe is here, I would say on failure, print std out and stdr if they were captured. Although that said, there's a bunch of stuff happening here, and then there's handle child process term. Although this is an else branch, so it means that process term here is only handled if none of these things are happening. So let's see. If run stdio was check, then we print check with the expected diff. Expect these, expect that. Okay, so to be fair, it makes sense that we actually do want to run this, do this stuff only when we get here, only when it's not just, only when we are not doing any checking. So I think that what we should do is here not just return term, but return all of result, which is a child proc result. So this is a child proc result. Where is this guy defined? Run dot, maybe? Yeah. Also, how many people are using this? Evolve child process uses this. That's bad. But I do have a run result, I think. Although, no, that one only returns. No, right. That returns a run result. Okay, so this is fine. FMT does run result dot term. Okay, you know what we can do? We don't change this. That's fine. But in here, so we leave also this like this. In here, we do the work. Also, my computer is uber lagging because I guess CLS is rebuilding all of Zig. On failure, print std out and stdr if captured. So here we do some work on exited, signal, stopped, unknown. So this seems annoying that we're doing these up. We should be doing it down here, honestly, because here is where we're switching on this stuff. The problem is we don't know if other functions invoking this function want that behavior. Like, does FMT want that behavior? I don't think it does. I don't think it does. We only want this on a run step, I think. Um we don't want, I don't know what's happening here, like we don't want step FMT to print on failure, I think. Although to be fair, with an FMT step we're not capturing. Are we capturing STDIO? I don't think we are. Yeah. And here we're already doing some specific stuff, so this is the right place. Result dot term. Okay, so what could have happened? It's exited, signal stopped, unknown. Expect a comma after the initializer. What do you mean? What am I doing wrong? Switch result of term. Oh, I'm missing a T. There we go. Hmm. I think we want an if statement. We don't want to switch. Oh, here's how we do it. Wait, I had the solution. We do want to switch. Const bad exit equals. There we go. There we go. Hey, I actually know how to program dig. If bad exit, then we do if result dot stdio, and then we have a std out stdr. Okay. Where do we print std out now from that application? So normally it would go to std out. So I guess we redirected all of it to std out. So std dot oh shit, what is it now? io dot file dot std out. Is this actually it though? Yeah, no, I think we're being sent to the wrong we're being sent to the wrong file. Is there a file in here? No. It's in a fast file, huh? Yeah, so this is what we should be doing. So this is fs.file dot stdout dot write all out, and we try. stdr. Do you have access to stdout somehow? What does fail do? Add error. It depends. It depends this stuff. Hmm. Although for stdr, I think we don't want this. We want std.debug.print. Like this. I think this is how it should be. I'm not sure. How are you doing? What are you working on today? Hello, Viper Gamings. What am I doing? I'm making APR to the Zigbee system because I want a different behavior. And so I'm doing that. And then I'm working on a GitHub action that I made. And then I'm fixing my static site generator because it has more bugs. Now I have users who keep stumbling upon my bugs. I don't get it. Let's see. I don't have all the context. What are you running that prints to std out? Any executable? Like if you have a run step that runs a program, you know, when you do like add system command, for example, if that command prints to std out, you normally see it in your terminal. We can test this actually. You know what? Let's test this right now so we can confirm that I'm not like hallucinating these ideas. So let's do mkdir. Let's go and test mkdir build, and then we do zig init. Maybe we should do zig1 init. Can I do zig1 init -m? Oh, well, right. I don't have -m. Let's do zig init. And for now, we make do with -s. Okay, so then in our build.zig, well, here's an example. Add run artifact, right? This runs an artifact. This happens to be tied to the run step, but it doesn't have to. So we have a step that runs an executable. Zig build run. And with this, we see all the output. If we do -- summary all, we see the output, and then we see also the summary. We can even simulate more precisely what I'm going for. So let's say that our main has the problem that it always fails. So return error dot oops. So we just do a normal run, and you see that in a normal run, we see everything that it prints. This is all that it prints. And this, I believe, goes to standard out. This goes to standard error. And this also goes to standard error up until here, I believe. And then we have the report from the build system. So what are you running the prints to standard out? In the build system, pretty much whatever you want. In my specific case, I'm running Zen tests on my CI. And because I'm capturing their standard out, if they fail, then I don't get to see what they printed. And that's what I want to do. And you can't solve this within the build system itself. You need something you need something to be different, basically. Long story short. Okay, so this is the behavior that we want to emulate, I guess. So I have this change. All seems fine. Let's test. So here's also what we want to do then. Do we need to rebuild Zig? I don't think we do. So we have this behavior in Zig 1, while Zig without the number doesn't do it. So here's what I'm gonna do. In here, I'm gonna do hx. I'm gonna change my build.zig to capture the output from these guys. If you just printed your test failure to STDR, would it show up? If you just printed your test failure to STDR, would it show up? My test failure does print stuff. Like the command here in Zen, in the Zen CI, this command, as it fails, is, I can't say this for certain because I haven't seen it, but it is almost certainly printing stuff. The reason why we don't see it here is because we are capturing this. This build script is designed to capture the output of this command and write it to a file. So let's simulate this. Run step, run artifact. This is the run CMD. So now we do also capturing. I wasn't sure if run step may already dump STR when it fails. Well, we can test this now, but I'm fairly confident that it does not. Because it doesn't, yeah, it just doesn't do that. It doesn't have any dumping implemented anywhere. When you see it, it's just because it's doing pass-through. It's doing inheriting. But you know what? Let's test this now. So, okay, you see now that if I do zig build run, I do see, so I have designed my executable to fail. So the run step prints standard out, prints standard error, and then shows the error stuff. So this is what you normally do. It dumps if you pass an expected output. I'm having trouble parsing what you mean with this sentence. But let me simulate losing this. So we know for a fact that when you do a run step and the executable that you're running prints and you're not capturing anything, you see everything in your terminal. You see this. You see all the output. You see even the stack trace in this case because we are returning with an error from main. So you see a bit of a stack trace. Well, I think this is technically still an error trace, but in any case, you get the idea. And then it prints the build summary with failures. Okay, let's change this. So I'm gonna do underscore equals run cmd dot capture stdr. I don't know. I don't remember how the function is called. Uppercase E. Yeah. Okay. So here we're capturing standard error, and here's my prediction. We are gonna see all your code base are belong to us. Let me double check. No, this goes on standard error. This goes to standard out. So we're gonna see this because this goes to standard out, but we're not gonna see all your code base are belong to us, and we're not gonna see the error trace. Keep in mind this is Zig without my changes to the build system. And there we go. Oh, we actually don't see shit. Where is standard out? We're not seeing standard out. What? What if I change the build script? Where is it? Just standard out. So we just standard out, we see standard error. But with standard error, we don't see standard out. Is this me not reading, not noticing something that is obvious that I'm not seeing? No, we are not seeing standard out. Although, you know what? Standard out is a single line. Maybe it's just get deleted by the summary printing code. Let me change what we put to standard out. Main standard out. Oh, where is it? Buffer print. Let's add another new line. Banana new line. Something like this. I don't know. Just to say something. No, we do not see standard out at all. So if you call expect STDR on the run step, I believe we will print the actual output if it doesn't match. Yes, but that's a different behavior. That's not what I want. I want to capture, but I don't want. I don't have a specific expectation. Or rather, I could change my build script to try and do that, but that's not the behavior that I want. The behavior that I want is capturing and writing to a file. Period. The problem is that if then the executable fails to run, then nothing gets saved and I don't see shit. By the way, this is interesting. If we try to grab standard error, even just one of the two causes the other one to not show up. That is interesting. In any case, so now I'm going to try to run this with Zig1. Zig1 has my change, and in theory, now we should see everything, even if it's captured. So for completeness, I'm going to capture both STDR and std out. Again, run everything with normal Zig, and we don't see anything. Zig1 build run. Let's see what happens. There we go. Now we see some of the printing. Then we see standard out. Oh, the problem is that this printing is not well coordinated with this stuff. Maybe, you know what, Johnny? Maybe you are right. Maybe there is some code that coordinates even when you don't capture. There is some code that coordinates printing from children. But in any case, at least we see everything. So with this patch in place, we would see everything that we want. The problem is that the standard out does not synchronize well with standard error. But actually, we can do this. This is actually not that complicated. We do basically exactly what this guy does, which is we call lock STDR writer, and then we unlock it. Also, I don't understand why there's a buffer. BW. Lock STDR writer, let's see. Allows the caller to freely write to STDR until unlock is called. During the lock, any STD progress information is clear from the terminal. Returns a writer with empty buffer. Wait a second. This is not... We're going into the wrong STD lib in any case. Debug. Function print. Yeah, it works the same way, but at least now we're in the right file. So it uses a 64-byte buffer for formatted printing, which is flashed before this function returns. So what we could do, honestly, another way of making this work is to do this. We lock STDR when inherited in std run spawn child and collect. Just look for the lock STDR call in there. We have one. I see. If inherit. Oh, would you look at that? So I guess in our case, we can do this unconditionally, but also, wait, does this not have, wait, does this not have the buffer stuff? What was I reading earlier? Oh, I guess this is internal. No, this is public, but okay, okay, but this is just one interface. There's also the other more normal interface. Understood. Okay, so we can do this, lock stdr, and defer unlock stdr, and then print to standard out. So we don't have to print to standard error. Okay. Okay, let's see how it goes. Yep. Now we have it. The extra banana here is my. Why are you printing to std out? That should most definitely be on stdr. You mean also the std out from the application? Is the application not printing to std out when it to your std out when it prints to its std out? I mean, I'm fine with that. Honestly, I don't have a strong opinion. I'm just trying to just explain to me the reasoning behind this stuff. I'm happy to oblige. By the way, I'm printing stdr to stdr. I was just printing std out to std out, just for extra clarity. Let's see, you should go to stdr invariably because the user hasn't requested the stdio stream to be inherited. You're just printing the data because of an error. The user hasn't requested the stdio stream to be inherited. Okay, because so you're saying that that doesn't happen normally. But normally you do see std. You know what? Let me test this out for a second. We don't capture anything. We use zig build run. I said we don't capture anything. We use zig build run. We see all the prints. Let me, oh, sorry. Also, let me remove the banana stuff, which is driving me kind of nuts in here. Okay. So we see this. If I do send stdr to a file, would you look at that? Normally, std out goes to std out when you're not capturing anything. Yeah. I guess my point is that that's what I'm trying to emulate. Again, I don't see necessarily a problem with printing to stdr. I'm just not understanding your reasoning. By default, if you don't do anything, you will see std out to std out. So why should we not emulate that here? Because you're not doing the default thing here, you're printing solely because of an error. You're printing solely because of an error. If there would have been no error, we would not have printed. Correct. But that I get it. So yes, we are doing the printing only because of an error. Why does that should imply that printing to standard out is wrong? I mean, if again, without capturing, if there is an error, we still get by default the print to standard out. Let's see, run steps don't always inherit std out. That's just because it's assumed to have side effects, so it's assumed by default that the output matters. Hmm. Does this help? SDR is by convention not captured. It's like a way to short circuit the process hierarchy if you want your output to be visible by the end user. One use case of SDOut is programmatic parsing. Its output should be consistent. I'm still not sure I follow. But okay, you know what? Doesn't matter. Uh, Even better. Pure lines. Okay, you know what? I can even put everything on a single line. Why not? There we go. No space even. So, okay, we have it. So this works. This would unblock me on the CI basically. Let's see. If you print to std out, your output might be captured, password, processed, and never get to the user. If you print to std out, your output might be captured, parsed, processed, and never get to the user. But that's what happens by default. Let's see. So like if I run Zigbee run and I have set up my step graph so that only that run step will print to std out, I then expect the only std out I see to be that. The rule should not be violated in error conditions. Reporting error conditions is the job of stdr. Let's see, if I run Zigbee run and I have set up my step graph so that only that run step will print to std out. I have configured my graph so that only that run step will print to std out. So you're saying all the other ones. Okay, I think I'm starting to understand. So you're saying all the other ones were actually configured to capture std out, and my expectation is that none of the other std outs should ever reach me. But then one of those things fails, then you maybe would want to see what the heck happened, but you don't want that to reach std out, even though the original application, the original process, the sub process was printing to std out because I'm capturing it. Okay. Um, okay. Perhaps I make a shell script which invokes Zigbee run and parsers its std out. Yeah, I get it, but I mean, what I would expect that you also look at the exit code, right? So a non-zero exit code should mean something, even if you see output to std out. Either way, if you guys are convinced, I'm fine with it. I might be streaming std out rather than buffering it at all before child exit. Sure. So that would be seen by other things, but I mean, still, regardless, you shouldn't be committing to any side effect before observing the exit code, I would expect. Like, let me put it this way. Let's say that I'm capturing every other output and I'm leaving this one, this step here, this run step here, not captured. and then I'm setting out a pipe, then what I would see is this output to std out, and then a non-zero exit code. That's something that you have to handle no matter what. Like the fact that you see std out does not guarantee success. I guess your point maybe is, well, maybe I'm designing it in a way that printing to std out should only happen in the case of basically having already succeeded. But you can't do that. You can't guarantee that with a Zigbee script, can you? In any case, Zigbee system, print, captured, std out, std r. So we're running so when a run step captures std out and stdr, when a run step that captures std out and stdr fails, no output from it is visible by the user. And since the step failed, any downstream step that would process the captured streams will not run, making it impossible for the user to know what happened. Well, to see. From the failed process invocation. Let's see, what are you guys saying? You can always guarantee that what appears on std out is only stuff that you have explicitly asked to go to std out. Sure, maybe Zigbee run is running a binary which outputs JSON to std out, and I'm doing Zigbee run pipe JQ or something. Sure, and that I totally get it, but there's no way for you to make this work and guarantee that if JQ sees anything on the pipe, then the exit code will be will be zero. Like the Zigbee run is guaranteed to succeed, I think. Well, let me okay, I'll read more in case that you replied to this point already. Let's see, or something with JQ streaming its input, so it's not gonna wait for Zigbee run to exit before freaking out. Sure, but I mean, but that's something that you can't avoid. I think you can guarantee that if JQ sees anything on the pipe, that will not be malformed to JSON. True. That is correct. Okay, that is correct. And the problem is, if when the user is capturing std out, you don't know if they're capturing std out for processing or if they're capturing std out for just for the purpose of preventing it from getting to std out. I think I now understand the point, or rather, I understood this at a general level, but I think this is what I was missing. Like the fact that for you it's available, that it would be available to guarantee that you don't see, that at least you don't see garbage on std out. The exit code, I don't think there's protection there. Like you will have to react to a non-zero exit code. let's see, I didn't read this middle part. The thing which makes this a bit more confusing than it would otherwise is that stdout inherit is the default behavior in certain cases that's still able to specify an inconsistent behavior, i.e. stdout is always inherited regardless of success or failure. Okay. Let's see, build system print, capture stdout and stdr. On run step failure, when a run step that captures stdout and stdr fails, no output from it is visible by the user, and since the step failed, any downstream step that would process the captured streams will not run, making it impossible for the user to see the output from the failed process invocation, which makes for a frustrating puzzle when this happens in CI. By printing to stdr all captured streams, we guarantee that the user can see what the failed step. Well, I mean, this is a bit too verbose. I mean, the point is already made. I guess maybe we should talk about this stdr stuff. We print both stdout and stdr to. We print both. The run steps, the runs. The run steps stdout and stdr to stdr to let me see. So why do we do this? What would be a good explanation, like a succinct explanation of basically what we're trying to avoid? Let's see. By the way, this is the same problem in ZigUp, if I remember right. That's one reason why I switch all my tests to Zig build run steps. To Zig build run steps from what? From being actual Zig tests? Okay. Well, you know what? Then I'm gonna leave it unsaid. Fuck it. I think this is enough. Git push. And we can go make a PR. Okay. And now we're gonna wait for all the freaking tests to pass. Oof. Oh no, wait. Do I know if the tests will pass? I actually don't know that. Well, I guess we'll see when it happens, I guess. Is there like quick invocation for like running a non-insane amount of tests just to smoke this stuff out locally and maybe prevent some inevitable failure before it's too late? Sig1 build test. It's probably better to pass this data to std to step.fail. This is what Johnny was suggesting earlier. I don't know. I think it's fine. Like what is the big difference there? In the end, you normally see this information as it comes from the application. And that's what's happening here as well. Can you pass in a particular source file for only the tests from it to be run? Yes and no. So you can do zig test path to my file.zig. That works, and that will run tests from this file. But if your file is part of a project that needs to, like, if it imports other files and maybe you have like dependencies even, then you can't YOLO a single file. You need to run this in the context of the build system. You need to have an invocation that properly wires in all the dependencies. Also, you have another problem with the root path. Like if you let's say that your project doesn't have dependencies, but if you try to run this file, then your root path will be this one, like inside here. And if this file tries to do import dot dot and it tries to go up, then this will fail, because for your projects from like when you have everything set up correctly in the build system, your entry file will be a root, which is maybe path/root.zig or main.zig. So this file doing importing stuff from above is legitimate as long as it doesn't go more up than where main.zig or root.zig lives. So these are the two practical problems that you will encounter. So long story short, the approach for this is to just make sure that your tests are correctly wired towards the entry point. So you correctly pass them, import them up into the entry point. And yeah, and so that way you don't even have to run tests on a specific file. Also, lastly, if you just make changes to one file, the Zig will not run all tests. It will only run tests that make sense to run. So, like, there should be no downside once you have everything set up correctly. You don't normally see it. That's the behavior if the stream is inherited. On error conditions, such as the aforementioned expected this but found this, you do not see it immediately. The printing is handled by the build runner. Yes. You see this behavior if the stream is not captured, basically. Yes. On error conditions such as the aforementioned expected this but found this, you do not see it immediately. The printing is handled by the build runner. Yes. If you pass to stable or fail, then the build can coordinate output. So if you get parallel errors, they won't be interspersed. Yeah, that's also a good point. But in any case, in this condition, so in this case, we do not do this printing also. So it's just a different thing compared to what we're doing right now, but sure. The core point here is that I'm printing it because something went wrong is a completely different scenario than I'm printing this stream because it's the behavior of this step. Is it? I'm printing this because something went wrong is different than I'm inheriting the stream because that's the behavior of this step. Yeah, to some degree. Yeah, I know that it does print. My point is, like, we're not doing the printing that I just added. We're not doing it in that case. Like, if you have expectation, if you have expect this or expect that, then I don't print anything with the current implementation that I wrote. Oh shit. Where's my Control C protection? God damn it. uh, Sorry, I only have YouTube chat now. We lost all of Twitch chat history because of the reboot. Let's see. Okay, so how would we change this then? This is annoying though, doing it this way. So the way we would do this. So the way we would do this is that we would need to add another argument in here, because the problem is that we can't implement this code in here because this function is called also in other contexts. So it's called by oh, we're not seeing it now. Interesting. Why are we not seeing it? I think ZLS is having a moment of stroke, but this is also invoked, I believe, by yeah, FMT as well, for example. So FMT also calls this, and I guess with FMT we don't want to do that. So I guess we need another argument or two. Try alloc print CMD. Let's see, what does it print normally? Like, what do we see when it's, there we go. Error, the following command exited with error code 1. So where would you put this output? Below it? Below this? Above it? Maybe above is not a bad idea, between this and this. Report as a DR via step.fail. Do you think you should go below the command? Okay. Maybe making the optionals is not a great idea. Let me see. You think it would be fine for FMT steps to print this? Okay, so if you think that, then we can do, let me think about this for a moment. I guess we can do this then. Let's see if we can do this. Child proc result. Let's see if we have this everywhere. Okay. You know what? I think that having a couple extra arguments is not a bad idea at this point. Okay, so we have these two guys, and then we say with the error code this. The problem is that they don't have new lines on their own, so we need to add new lines. This is annoying to compose with FMT. So what's a good strategy here? Let's see. Here's an alternative to including it to fail call and error with SDL call stuff. You can just associate multiple errors with a step. It turns out I forgot that fact. Oh, can you? You're saying you can call an error on what specifically? In fail colon. So you're saying what this returns, what does this guy return? Oh, it applies a side effect to the step. I see. It applies a side effect. So you're saying that we can do this on the outside even. Okay, so in here instead of printing, so you're saying we do step and error, right? No? Wait a second. Is this really not it? Do step. Yeah, it's s.fail, and s.fail calls step and error. And yeah, this is the same step, so we should be able to do step and error. Wait, was it and error? Wait, am I like dumb and it was and error and I didn't notice? Yeah, that was it. Okay, so and error. Can I see the signature? Come on, man, just give me the signature, really. Oh, add. Oops. Yeah, I'm dyslexic, I guess. Can I see this? Okay. FNT, blah, blah, blah. Okay, so we can even do something like std out colon slash n. Oh, this even can go on a single line. Uh, this? Nah. Okay, I'm sorry. We're adding curlies. We're curling it up. Okay, let's see how it goes. Well, I think I commented some stuff out in the build script. Error union is ignored. Oh, this can fail? What does it do? Return out of memory. Okay, so we try this. SCD out, SCDR, error, the following. Man, is there add error? Is there add something that isn't an error? Like add info? No. Try it again from the error. Let's see. Oh, you're right. So I'm guessing that this thing starts with prepends a new line then. That's why we don't have to worry about it ourselves, huh? Do-do-do. Yeah, that seems good. Okay. Mm-hmm. This can be canceled. I would expect this to cancel on its own, right? Oh yeah, it is canceling on its own. Cool, good. Okay, so it's canceled. That's nice. Okay. Okay. So this seems not bad. We did our PR. Well, thank you for the help. Sorry, to me it wasn't immediately clear why you wanted to not print to standard out and why do things structure things in a different way. From my my initial idea was to basically mimic what would happen if you did not do the capturing. But I understand that if you are doing the capturing, then you might be expecting some other guarantee, some other behavior that you don't want to happen because there was an error. So that part I get. Yeah, overall this seems nice. How much does the ACI run cost? Coffee time fun. That is a great question. The answer is it doesn't cost kinda well, it doesn't exactly cost anything, but the point is that we are renting actual hardware, and some of this hardware is actually physically hosted by somebody in the Zcore team. So um, we're not paying per run. Custom runners might not even be using SCDIO. Mm. So sorry, going back to the CI run is yeah, we're not consuming any cloud. We're not consuming any shitty cloud resource um, from that perspective. I guess we're getting some cloud component for free from GitHub because GitHub is basically coordinating all these jobs from the cloud, from Azure specifically. Like, can you fucking imagine that GitHub is running everything on Microsoft infrastructure? I think that if the average GitHub population fully realized this fact, they would throw up in their mouth. I kind of do a little bit when I think about it. Can you imagine? Like, can you imagine that these people decided that we have to implement action runners? The client that goes on the actual machine that runs your CI tasks, and they said, look, we need to implement it. Which language should we use to implement a runner? And their answer was, I think it's actions. Oh, is it not actions? Let me see. Their answer was runner, I guess. Let's use C#. Oh, this only has a readme. Wait, what's going on here? Wait a second. What's happening here? Usage git checkout arch. Oh, here's what's happening. Okay. So basically they made it in .NET. And the problem is that .NET is not portable at all. It turbo fucking sucks. And it didn't have to be .NET. It had no reason to be .NET. But it sucks. Yes, it is a little bit portable because now there's .NET Core and you can get .NET Core on Linux, except that most distros don't want .NET Core on their distro. Nobody cares about packaging that shit. So the major distros, they will have it. Ubuntu has it, cool. But then you want to run your CI on a non-standard Linux distro. Then the question is, do you have .NET? And the answer is usually no, you don't have .NET. Do you want to run this stuff on FreeBSD? And the answer is no, there's no .NET on FreeBSD. And so also you want to run this stuff on a non-standard architecture like S390X or RISC-V64. And the answer is no. Like Alex had to fork the goddamn runner and implement support for these other architectures. Let's see how he did it. It's probably not too bad, but so he adds something in an XML file. Delightful. I'm already in love. Then there's a PS1 script. If runtime equals .NET, If runtime equals ASP.NET Core, Windows Desktop. Oh no. Yeah, I know that it's all .NET, but I don't respect their brand, so I don't care about saying things the way they want me to say it. So this is pain. So holy shit, Alex forked the .NET SDK. We're gonna look at that next. Okay, so external SH, package name, Linux RISC-V64. Man, good thing that he likes .NET because, like, unless he had, if he didn't have this weird fetish, uh, who would have done this work? Like, I did a bunch of CI work for Zig, and I enjoyed it, and I'm happy to contribute to CI. But if you were to ask me, can you please fork the fucking .NET runner and make it work on other architectures and OSs? And also, by the way, to do that, you need to fork the .NET SDK. I don't know, man. I don't really know if I would want to do this. I don't think I would really want to do this, to be honest. Also, forking the .NET SDK? What? Is this a branch thing? No, it's not a branch thing. It's based on Philip Navarra .NET RISC-V. These builds are only intended for use with the runner. Arch options. How does it even work? It runs Docker run. Okay, which wait a second. Where do you see the image that Docker is running? Volume, worker, environment. This is the command. Wait a second. Where's the env? Where do you see the image invocation platform? Oh, you don't see it because it's wait. Is this based on a Docker file that is in the current working directory? Is that how it works? I haven't used Docker in a while. I'm forgetting how it works. Docker run executes the Docker file that you have in your current working directory, doesn't it? Git clone single branch depth1.net uses edit garg 8 remove unwanted software at v5. Docker run takes an existing image. Okay, so where's the image specified though? Oh, I guess it's this argument. Oh, I think I get it. Right, it's the one thing that doesn't have a flag in front of it. Okay, now I get it. MCR Microsoft.com .NET build tools prerequisites are Azure Linux 3.0 blah 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 blah. Jesus. this needs to be set to a hash for better ref than this one. Okay. Ben, what an adventure. Okay, so point number 1 done. So we should look at code owners auto merge and then do some Zen fixing. Although, while we're in the business of messing with the Zig build system, maybe we might as well test this stuff for Zen. So, okay, here's question number 1. Do we have CI in place for PRs in Zen? I think we do. Let's see if we do. Yeah, okay. So we do check PRs. This is great. Okay, so we can let's go to Xena now. Git status, cool. Git switch dash C CI test. Switch. Okay, and in CI test, we do this. Zig capture stdr. We don't capture stdr. You know what? Maybe this one we can leave there. This one is the one that we don't do. So we comment this stuff out, and then we copy this one, and then we say run Zen. Okay. Send to a branch. Do we actually just run actions on branches by any chance? No, why would we, right? Yeah. But we can make a PR out of it. And we want to take a look at Ubuntu because it's the one that fails. Mm. So I guess we are basically looking at Zine being recompiled, I guess. Attempting to restore from cache. Cache hit. Oh, we did have a cache hit, so I'm surprised that this is taking this long. We did change the build system, but I would expect this to hit on the Zen executable, but maybe not. There we go. We finally see the output. Oh my god. General protection exception. No address available. Why the information for libcso was not available, trace may be incomplete. General protection exception. What happened? We're trying to access CTX items A, and that is a problem? And this is happening in our sorting code? S.sort pages. Is this a problem where we are not passing around pointers? Means that S pages is corrupt somehow. Insert pages. For build variants, for sections items, S.sort pages. You know that this might be right. I think I have a vague memory that we should not access the first section. I think the section 0 needs to be skipped for all this stuff. Let me double check, because somewhere else we do sections. Yeah, elsewhere we always do. We start from 1. We probably want to do this because the 0th section is kind of a sentinel value. I think this is the problem. Well, we can test this directly in our branch /pr. Kind of surprising that none of the other ones complains about this. Although also, so no, never mind. It's not even this one. Oh, now we have another problem. Integer overflow. Integer overflow in sections.items the init the GPA. Oh, there we go. We're hitting again the problem that section 0 is weird. Okay, let me double check why section 0. I think that section 0 has to be weird because of a variety of reasons. I guess I could probably make it less undefined and define it a little bit more than what it is right now. So here we're doing this. Okay, where do we care about this stuff? It's in build, I guess. In build, we create variants and stuff. Let's see, load build. That gives us a build that contains a CFG build assets, any preliminary error. Yeah, there we go. It contains all the variants. And so here we do all the variants. Oh, it goes to worker, everything. I guess everything goes to worker, does it? Oh, we don't do variants. Okay, never mind. So this is all orchestrated by root. So up here we do this stuff, I guess. Let's see. Field, multilingual, add job for each variant. So worker add job. What is it though? Scan. Right, scanning the variant makes the variants. Okay, so we want to go to worker. Excuse me? Open file picker? Why can't I see the file picker? E. Oh no. Oh no, why did he switch to Colimac? I mean, I have Colimac. It's just like in my keyboard, like in my keyboard. So if the system switches to Colimac, nothing makes sense anymore. Worker scan calls variant scan contenter, and this creates sections. Section 0 is invalid. Yeah, we know that. Does it have to be undefined? Can we do better than undefined? I guess we could set it to things. Oh, there we go. It also has pages that is empty. That's interesting. You know what? The thing is, accessing section 0 is, generally speaking, truly an error. So, you know what? Being able to catch this is not a bad idea. Variant.zig the init. Variant.zig 181. So there we go. So here we're calling sort on section.items, and I bet you that it's based on looking at things that we should not be looking at. Like the section what? LHS and RHS are the sections. So we do LHS, content subpath, RHS content subpath. Yeah. So we should do this on like this, I think. Okay. Let's see how CI goes now with this. Only 2 tests? Oh, this is the Nix stuff. No. Let's see, I just spent 20 minutes trying to figure out why I broke the fuzzer before realizing that it's just that it's broken anyway. Yeah. Yeah, I think that a bunch of stuff regressed. Like right now, I believe that it even has a invalid access to the program counter array that always pops when you run it in debug mode. Okay, so what happened now? $35 out of 40 steps succeeded, 1 failed, transitive failure. Running the camera failed now. The fact that the running the camera fails, it's interesting, but also where's my wait? It just prints this, and that's it. So I changed a thing here in the bug, and I think this might have changed the behavior of something. I don't know. Build.variants. We do sort on section items 1. So this should be fine. And then we do the printing only for section items 1 following. So we were already, so here this was correct. This was wrong. This was correct. Are we just observing like a difference in the diff or something? No, that's not it. Let's see. Zig build test. Let's see how our test goes. The invalid array access is just caused by trying to do it with self-hosted backend. Oh, I see. Because our elf linker fails to define some symbols properly. I see. So, oh shit. Of course the test fails. I think I know why the test fails, because we need to go to build and restore the capture stuff. No, that is not true, because we didn't change. This is not what's failing right now, though. What's failing is the debug invocation, and we are capturing. Oh, here, yeah, right. Here's the problem. We are capturing fucking SCDR, and so we don't see why it fails. But don't capture anymore, and now we should see. What am I doing? Okay, so now we should see. Okay, now we have to wait, I guess. Do. Let's go. So build failed. Yes. Let's see. So we have all the errors. So I think these errors are fine, because these things are supposed to print errors, but they are not supposed to reach unreachable code. Pointer stability assert unlocked. Constcast? What's happening here? What is happening? So we're calling. We are the anything in the build. And to the init the build, we are the initting the templates. And to the init the templates, we are the initting the AST of a template. Which makes us do this. What the heck is this thing? Const cast. Um, hmm. Let's take a look at this line. AST 213.7. What the heck is going on in there? $237. We const cast stuff to call the init on it. No definition found. What do you mean? So interface is just an array, hash map unmanaged. Why do we have problems with it being this way? So, okay, I understand why we were doing this. The reason why we were doing this is because um, we are fine with the anything, like we don't want a mutable pointer to this AST to the init it. But unfortunately, some of these thingies, like interface, they want to be mutable to be the init function, the init. They want a mutable self, and then they do assert unlocked on themselves in debug mode. Well, when there is runtime safety, they assert that l.state is unlocked. But then, where is this actually locked? Where do we lock this stuff? Because I'm not sure I even use this API. I might be wrong. Maybe I do use it. Yeah, every usage of the word lock is because it's part of block. I guess the question is, what's the public API for locking the hash map? Lock pointers, unlock pointers. Okay. Do we do lock pointers and lock pointers at all in here? We don't do any of this stuff. And also, pointer stability debug safety lock. By default, it's unlocked. And since we never lock it, then this comparison should never fail unless we're dealing with corrupted data, basically. I guess that's what's happening. Assert that state is unlocked, and instead it's not unlocked, I guess. Is there any other error? Is this happening again? No, there's only one test that triggers this. Okay, maybe we should take a look at what we're doing in that test. Let's see. So this happened in camera, child process, blah blah blah. So it's a camera invocation. Do we know anything more? I guess we maybe could learn here what is going on. Oops. So it's a text that has oops.html, I guess. Oh, you know what it might be? Okay, I think I'm starting to suspect what it might be. Maybe it's a template that went through parsing, but not analysis. No, but the fact that we have a template means that we went through analysis. Hmm. Interesting. And also we do have reasonable initialization every single time. So when we return an AST, I'm guessing these guys are also set. Where's our init function? So we make a parser. We do the node stuff. And then we return its values. But these guys are reasonable. And if we fail, we don't return this value at all. So we don't call parser.deinit, do we? On failure? Only on error. Error defer p.deinit. We don't deinit on success. So there is no, we're not like freeing stuff. We shouldn't be freeing here, I think. I feel like you've been fighting compiler errors more lately than you used to. Sorry, I already read this message, but I just realized it. Be aware that this is not a compiler error. This is a runtime error. So the compiler has happily compiled my code, but then we ran it, and stuff that shouldn't happen is happening. All the previous errors that we saw were 100% my fault, clearly. Chances are that this one is also my fault. Uh, but it's not immediately clear to me why this is. So, well, let's try to find this one and see what happens in the example at the very least. Or, you know what? Let's start maybe from debug. So in debug, let's see, we start the worker stuff. Oh, nice that this still works. So this ended up not being broken. That is so nice. But I'm actually surprised. I thought this was going to be broken in any case. Let's see. Since this is Zig office hours, it kind of is always Zig office hours. Yeah, it's not broken yet. Oh, okay. Yeah, that's why I remembered correctly. Unfortunate though. It's such a nice construct. It's so unfortunate it is like unsound, like problematic. Since this is Zig office hours, how can I make a C pointer C mini pointer to a C mini pointer U8 out of a Zig native thing? Like, what would be the Zig variable type needed to be? I've tried optional pointer 0U8, but the compiler isn't happy with me. Yeah, because you are missing one level of pointer interaction. So you are correct in saying that many pointer C could probably be turned into a optional many pointer with an null terminator. That is the most generic way of translating that to this, which also prompts the fact that if you know that a given pointer is never going to be null, then you can omit the question mark. Just pointing this out, you don't always know that, so if you want to be defensive, then you probably want to keep it around. But yeah, so your point would be that it's a star colon not zero but colon null, because it's pointers on the outer layer, and then pointer like question mark pointer star colon 0 U8. So this is the type that you're looking at. It's so this. Let me translate this to types that know about length, about their own length, which obviously is not the same thing, but this helps like visually understand what's going on. So this is basically a U8, if it knew its own length, and this outer layer, it's another slice of these guys. So yeah, but I guess the point in practice then is that I'm assuming that this is the like you want a like let's call it a defensive way of explaining this. Also, you know what? I said defensive, but that's the wrong word. Yeah, because also the fact that you expect null termination here, then this is not guaranteed. If you have something that contains length of any of these guys, like maybe the inner layer, probably not, because I'm guessing that the strings in here in the inner layer are all going to be different length. So I'm assuming they will be null terminated. Although you don't know that for sure. You need to double check in the code or like the CPI. But then on the outer layer, you don't know really if it's null terminated or if you have length somewhere else. So assuming that you don't have the length anywhere else, then it's these guys. If the outer layer gives you length information somewhere else, then you have to take out the null because there's not going to be a null sentinel unless they tell you the length and they also put a null sentinel in there. In any case, this is the idea. So I'm printing all the variants and then I'm returning. And on return, we freeze stuff. Yeah, the fur is built in. Dot mode is debug. We also do a init of build, and that's what's causing trouble. But this is just root.run. So this should have given us a good build that we can free, even if there were errors. So I guess the problem is the presence of errors made us return earlier and has caused us to leave certain stuff not defined or something. Compiler still not happy. I'm going to have to dig a bit more. Can you print the error message? Sorry, but not in chat. Like, can you paste it on zigbee.io so we can see the error message? So we print everything correctly, it seems. Page, bad HTML, bad HTML, bad extend, another. And that on the way back fails. Weirdly. And it fails because we are in build.zigline 88 trying to init all the templates that we got, and one template poops itself. I think we should try and print what the template is. Hmm. Okay, so let's make this more interesting, I guess. Templates dot entries. What's a template? It's an array hash map. Okay, so I'm guessing the name is the path. I need a break from the current task. Where is the failed workflows stack trace? See if I can spot anything. It's on. If you're talking about the one in Zen, it's one of the like the latest action, the latest non-Nix, not the Nix one, the CI job, and it shows on Ubuntu a failure. So I can give you some context. These things are supposed to report a bunch of errors. That's okay. They're not supposed to crash. And the fact that we have a hash map somewhere that on the init complains about the pointer stability is undefined behavior. I don't lock these guys ever. Actually, you know what? I definitely don't do in Super HTML. Let me see if we do it in here. Yeah, no, we don't lock hash maps anywhere. So there's some UB in here. And it has to do probably with the fact that in the main loop, which is in Hello Rocket Rager, which is in root, we have early returns when we know we get errors, and I think that one of these things is causing some templates to be, I don't know, somehow undefined or something, which is weird. So scan templates. Dear stack, blah blah blah. So here we add templates, but I think that whenever we append one, b.templates put no clubber. Okay, so here's the key. The key is a path name. Okay. It's a layout. Yeah. Okay, there we go. Only present, the AST is only present if HTML AST errors length is 0. And I bet you that I'm just not checking this fucking property. Why am I so dumb to not check this fucking property, man? So if HTML AST.errors len is 0, then we do that. No, the const cast are fine. They're never const. These guys leave they live in non-const memory. This is guaranteed. This is it. So in Zen I have this thing where I don't use nullable values for values that only get initialized afterwards. I have these helpful comments, and then basically I made my bed and now I'm sleeping in it. Long story short, they are definitely not fine. You're passing by value. Oh. Oh. Yeah. Oh. Oh. Um. Wait, is this giving me pointers? Wait a second. You're talking about stuff by value. Where is this happening? The build is by pointer. The AST. AST.init. Oh, okay, so it's in Super HTML. This is the parser. This is the AST. I see. I think. Oh, let's see how we're doing with this. Though I think this is not what's causing the problem. I think I had that undefined, not being checked. That was the actual real problem. It was this. The fact that the template was not checking the condition that needed to check. Understood. Do, 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 do. Okay, I'm making shitty commits, by the way, because it's just a temporary branch where we are messing around with stuff to have visibility in CI. Let's see. In any case, I'm going also to the other project and fixing this. Um, I expect failures. Main 936. Main? Wait, what? Oh, LSP kit. Wait, what is going on? Fucking expected three arguments found. Oh, that's on me. Zig one. No, wait a second. Zig one? No, 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 no. Oh, I get it. This is like an error that I shouldn't worry about. It's or maybe yes. Well, I guess we'll see. Let's start with these other ones. AST 13,000. You know, it's so annoying having to make that shit mutable. I fucking hate this. Um, because I don't want to have to make them vars. It's dumb. Just because of the init that it's not even my the init that needs this. So here's the question. What if we don't worry about this and we just do, oh, it just enters the init and then header free, I guess. So I guess that's what we do. Does header free need a mutable version of it? It does want a mutable version of it. Okay, so here's what we do. Here's what we do. There you go. Bar mute AST. There you go. And this can be const pointer. Yeah, which one do you think is better? Let's do by value maybe. Like, oh, you're right, because we don't have the other thing anymore. Yeah, pointer. That's our. There we go. Okay. Okay, so now we have the only error in LSP kit. That surprises me that LSP kit is like this. Jesus. Okay. I left commented out code. Are you serious? No, I did not. Did I? Um. God damn it. Um. So we have a version of LSP Kit that is too old for our version of Zig, and then we have a version of LSP Kit that it's too new for our version of Zig. And this is so annoying. You know what? Let's update to latest Zig at this point. So let's do Zig up. Master. Give me latest master. Yeah, I need. There's just one perfect LSP kit that it's actually not even pushed to the repo. It only exists in the cache of Techatrix on one computer, which he has lost, was stolen, and right now it's like on a track going somewhere in Southeast Asia or something. And that is the only version of LSP kit that works for my setup. Missing struct field write buffer in CLI FMT. Okay. Oh, you know what? Wait, we should do this. CLI FMT 157. Okay. No definition found. Are you serious? Come on, man. Atomic file. I think I know why. God damn it. Config file. Zig path zig. Yeah, so what's your deal, ZLS? Why can't you find atomic file? Well, in any case, once we write buffer, that's fine. I think I could actually give it an empty thing since I'm not. Atomic file doesn't have write all. No definition found. Uh, okay, I'm gonna assume that this thing is gonna be pretty much the same that I have. atomic file has a file writer. Open file like this. Init the init flush. Name into place. Finish. Always call the init after a successful, even after a successful finish. Okay. Let's see. Okay, atomic file, destination path, options. Yeah, and then just returns an atomic file with stuff set. Okay. Is this it? No write all in file writer. Oh, because it's dot interface dot or dot writer. No, it's dot interface. Okay, so that gives me write all. Okay, man, what a thing. Okay, git status. Okay. Good news, this branch is approaching completion. Nice. Bad news, you have to rebase it. Well, good thing that what you're working on is nothing that has to do with any form of IO or dealing with like HTTP clients and stuff, which is in network streams, which is the unstable stuff that right now is being changed all the time and never works. Oh no, wait, it's exactly that. Okay, let's see if we are passing these tests in the meantime. Oh, look at that. Would you look at that? Now we finally succeed. Holy cow. Let's go. We have green CI. We finally have green CI. Okay, but at the same time, we're updating Zig version once again. So zone file, we have LSP kit. So Zig fetch, Zig tools, LSP kit. Prominent compile errors. See what's wrong. A bunch of stuff. Okay, gonna move it here. Serializer. Test stringify. Okay, the problem is the writer wants. Oh no. Oh, but it's a function. Oh my god. So this is not bad. Var out of type io dot file dot allocating. No, writer allocating. Testing allocator, defer out dot the init. And we stringify third argument is out dot writer ampersand, and it's out dot get buffered. I think this should help, and it does. There's more, but it helps. Generic function instantiated here. Error: IO writer has no members. IO writer has no members, so I guess stringify is trying to do weird shit. Wait, so we have IO writer in here. Okay, so we can do this. Okay, so we pass it down. We pass it down, and where is it that we're doing weird stuff? Serializer 48. Oh, type of writer error we're doing. Yeah, not anymore, man. What was this before? Type of writer. Okay. Okay. There is no buffered in allocating. Really? Hmm. Although I thought that what it was, it yeah, that's what it was. Is he really not buffered? Um. CD. Let's see. Going to OK Redis. Yeah. Oh, it's a fixed writer that has dot buffered. Okay, what about the allocating one? We go here. We can't. Okay. Let's look at our Zig source. Allocating one. Oh, because it's dot writer. There we go. It's probably dot writer dot buffered. From array list, the init to array list, ensure to own slice. There's two owned slice, but I don't. Oh, get written, which calls buffered on the writer interface. Okay, so get written is what we want. This is like the writer found generic writer. Okay. Do-do-do-do. Wait a second. Was Ziggy not updated at all to the new IO stuff? What is going on here? Am I on a weird branch and I didn't notice? I'm a main. What the heck? What? What? Did I really never update this? Maybe I never updated Ziggy with regards to its tests. Maybe? Hmm. Write all. Write byte and times. So the problem is what's write byte n times now? Write splat. Let's see. There's write splat. There's no write like single byte splat. It's just write splat in general. So write splat all. So write all is there. Write byte, write splat byte all. There we go. Writes the same byte many times. Bytes splat byte all. That's what we want. Okay, one error solved. fnt.zig missing strat field write buffer. Okay. Although to be honest, I'm really starting to think that this buffer is useless because we just do a write all. So what even is the point? You know what? I think the same should be true for Super HTML. Let's see if this runs though first before committing or anything because it might just complain at runtime. There's no write all. Yes, file dot writer dot interface dot write all. Okay. Okay, hit status. Okay. Oh, wait. Zone, do we update this? No, we did not update this. Okay, so this part is okay. So we can exit this. We can exit this. We can exit this. We can. Well, no, we can go to SuperMD now. Place Super HTML. We depend also on LSP kit here. I'm not sure why are we depending on LSP kit at this level? Well, in any case. No, I guess we have to hope that um never mind. I was saying we need to hope that this works, but it does work. Nice. So it seems that our dependencies are fine. Almost. CLI serve. JSON has no member named stringify unlock. Oh, new JSON, huh? Okay. There's a formatter that formats the given value using stringify. So I guess we have to use stringify with an allocating writer. I guess this is it. Let's see what's the signature of stringify. Uh, what? There's only an uppercase stringify. So you don't use stringify directly? Generally for matter, the formats the given value using stringify. So I'm guessing that's what you're kind of supposed to do if they're putting it here. So we need a writer, and then we do try aw dot writer dot print value then options. Like this. Well, whatever. Okay, so this should be it. Invalid format string S for JSON formatter. Oh yeah, you're right. Uh, yeah, it's F. And serve 50. Problem is we're expanding out of memory, and this thing is returning what? Write failed. Of course, it's returning write failed. Why am I getting that command as the first suggestion? I don't know. Let's see. There's another simplify unlock. We're gonna need this. Let's see. There's another one. Huh. Another one? No. It seems that we're happy. Okay. Okay, it seems that we fixed all the problems that we have. We now need to take these changes that we made and well, have them make sense. So we need to squash those commits. We need to uh, delete commits where we modified the build script because we never did any modification of the build script that was how can I say, not temporary. So let's look at the git log. Yeah, these comments are very shitty. So I think the one called test. Okay, let's do this. So the last commit is good. The second to last commit is not good. Second to last commit, we could remove. So git rebase -i interactive. Oh, I have message changes. Oh, these ones are good. Okay, let's do it again. So this one is good. Then this one is also good. So the first two comments are good. The third one is not good. Okay. Good. Keep it. Keep it. This one we drop. And actually, I would say we squash also this. Okay, so we have the good commit with more changes, with more good changes in it. Then we have a good arst commit, another good arst commit, and then a bad test commit. Okay, so we can do it again. So squash this, pick that one, drop this one. Well, this one does a lot of safe stuff. Fix a bunch of invalid accesses and update the. Okay, let's go to the git log now. Now I have this one that fixes a bunch of things, and then we go immediately into bumping Z version. Okay. Make sure that the tests pass. And they seem to do so. So I guess we can merge this stuff into master basically now. Let's watch CI succeed one last time after this last push. Yeah, this is going to take a moment because it needs to rebuild a bunch of stuff. Okay, so this one should be good. I guess we can just merge the PR at this point and kind of call it a day. Wait a second. Oh, I had this open twice. Wait, we're back to fading. Oh no. No, that's an old. Wait, that's an old one. Where did my other tab go? Or did this actually fail? Did this not fail yet? Okay, I was looking at something old. Do 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 do. Okay, so this all succeeded. Killing promotion. No, PRO is parameter reference optimization. Previously in Zig, you would be able to pass arguments by name, and the compiler would be able to decide on its own whether to pass the argument by value for real or by pointer. And that means by value means literally copying the value uh, into the function frame of the function that you're calling. That's not exactly precise because there are also registers, but the idea is that you pass down the entire chunk of data. And if the struct is small, then that's good. If the struct is big, then that's not good because, well, you're copying a bunch of data and it would be better to, you get to a certain point where it's better to just pass down a pointer and go through the pointer every single time instead of copying everything down. And the compiler would do this transparently on its own. But this feature has downsides also, and so it's being removed. There we go. Okay, so we ported all the important changes to master branch, well, main branch. Okay, so we fixed all of this stuff. So we have a PR that should fix another bug. Let's take a look at that one. Path normalization for build assets. Let's see. Currently, there is a discrepancy between how serve and build expect the installed path to be formatted. Since build will place serve and build, I guess it's release actually. So since release will place the file in the relative path of the build directory of the output directory, it expects an install path like static / example as. Yes, if you try to pass with a leading /, it will fail to build due to permission issues with accessing the root dir directory. Okay, so we are not even checking for that. That's not good. Serve, however, is checking the output path, which is equal to the installed path of each asset against the request path. The request path, however, contains a leading / like slash blah blah blah. So you format the installed path correctly for the build, it will be skipped when trying to access it from serve and vice versa. Uh-oh. Let's see, since I think it's more appropriate to provide a relative installed path, build's preferred format. To address this issue, I simply added a normalized path, which is just a trim left to the request path, only calculated once out of the loop to the server logic. This way, both serve and build will behave the same way, expecting a relative path without the leading /. Okay, so this is like a minimal change that makes this stuff work. But I guess the question is, we should not be trying to install files in random places of the file system because the user gave us a path that we don't like. So what should the user do? Should we force the user to use a specific version of these things? I don't know. I think in this case, we could be nice and not force the user to be aware of whether this / should or should not be there. And we could basically do this, but we also need to do this on the other side. So we need to do this on the other side. Two workflows waiting approval, resolve conflicts. There's also conflicts to resolve. I mean, this patch is changing fucking nothing, man. How can there be a conflict? God damn it. Oh, because they renamed this stuff, but I guess. Also, this is called main and this is called main. Good job, Git. You're really helping here. You're really helping here. Well, you know what? I can just do this. That's probably easier. Does build and serve use a different route for the path? Well, serve doesn't use any file system. So serve is this will come into main. Yeah, well, it's their main, not my main. So when you use serve, the files are never materialized on disk. They always stay in memory. So we're not really running around the file system, but we need to, when your browser goes to foobar/asset.jpg, then we need to map your browser's path to what the asset is supposed to be. So we don't have a concrete file system to query, but we have internally like a hash map with all these paths. So we check that. So to be clear with these changes, the server will skip if you do have a leading slash. So if you want it to be indifferent on the leading slash, just need to be changed. So if you want it to be indifferent to the leading slash, this will need to be changed. Wait, I'm not sure what you're talking about. So with this as it is right now, if I understand correctly, we are removing from path. We are removing the leading slash. Oh, I see what your point is. Sorry, you're saying this is not indifferent right now because okay, I get it. Yeah, well, this is not the full thing. How do we do this? Let me think about it for a moment. This branch cannot be rebased due to conflicts. Right. I have to make a merge commit. Okay, so let's make a merge commit, and then I'm gonna keep making changes on my branch. It's fine if the history is not super clean. No, not a big deal. Yeah, no, I get it. It's normal. I do the same. It's so that you don't make a mess, right? I get it. Okay, let's start to think about it. So the browser path, will always have a leading slash. The install path might or might not have a leading slash. So I guess we want to do is this. From the install path, we always skip the leading slash. And from no, what am I doing? From so this is the ba.install path. So we normalize the install path. Which is what we were doing actually down here. Yeah, okay, so it's like this, right? Path one dot dot, and this is std.vem.trim left. Oh, what was the signature of trim left? U8 argument slash. Does that make sense? We always remove the leading slash from the browser path, and we remove it if present from the path in the config file. Well, or wherever you specified this asset path. So this works, although I don't want to put the continue in there. It seems too much. Yeah, so this should work, and then we need to do the same also on the other side, because on the other side, like in release, we just cannot try to install stuff in random places on the hard drive. That's not good. Hopefully this isn't broken now. I guess we can, well, one thing at a time. Maybe we can test this. Do we do that, or do we? No, let's fix the other one. So serve. Serve is done. The other one is in root. The installation of this stuff happens in root, and we have asset installation in 2 places. We have, I believe, build assets and side assets in this file near the end, and we have page specific assets that I believe happens. Yeah, where the heck when the heck does that happen? I guess we'll see when later after we're done with this first part. Do. Here you go. Install build assets, install site assets. And this is variant assets install. Okay, there we go. So this is a job of the worker because there's potentially multiple variants, and we do that on the thread pool, while this stuff is sequential. Although it doesn't have to be, so we could actually schedule this stuff also on the thread pool, but that's an improvement for the future. Okay, side assets. Let's see, multilingual, blah, 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 blah. Iterator, path, and then we do update file on path. And here we can do std.mem.trim u8 path leading slash trim left. Okay. Build assets, I believe, is the same idea, except that these guys are here. Okay. And the final one is variant assets. So we go to worker. Variant assets install calls variant.install assets. Here, I think we have the same logic. Could we have install path? Well, we can do it like this, right? Okay, we have build errors. Let's see. Oh, it wants a string. Okay. Okay. That's fine. Okay, so this is working. Let's have a sanity check. Zin. Well, this works. Assets seem to be loading. Let's open something that has images in it. Yep, these images are loading. Let's make a release. Also, let's test the failure. Nice. The output directory is not empty, so we get a failure. Perfect. Output equals new git diff new public. Rob Pike. Oh yeah, that's a change that I made. Indeed. Class span variable client. So this is some syntax alignment stuff that has changed. The building public is a little bit old, so these differences were not introduced by us right now. Also, like this is a typo they fixed, so it's just a slightly old build that I have in there. So it seems that we haven't broken really anything. Okay, so we're good. Sanity check, I would say passed. Let's see. What do we call this? Fix asset install path usage. Previously, we failed to correctly. My base branch seems suspiciously functional. That's good. Failed to correctly deal with absolute paths in assets values. We now normalize them to relative to avoid trying to install files in random places on the hard drive. Okay, thank you. So this is done. I think what's left is either feature proposals basically and stuff related to Nix, which is a different story. Okay, we should have fixed this stuff. Cool. I'm happy. This is going really well. Let's see if our CI passes. Well, if Ubuntu passes, then then we're happy. Really cool. So this is done. So what do we do next? Do we do the polishing of code owners auto merge, or do we call it a day? Let me think. 4 hours of stream. Do we stop here? We could go on a little bit more. You know what? If I close this stuff, then we can basically be free to do ray tracing this weekend. So tomorrow and the day after. So here's my idea. For tomorrow and the day after, we can do, the idea is to do ray tracing on a weekend. In one weekend. And then there's the next week and then the rest of your fucking life. Well, I don't know if I feel like I want to commit to a life of ray tracing. That seems something like you really have to believe in it to do this kind of stuff. It's like going the monk life, I feel like. But one weekend, I would say we can do. Oh shit, it uses C++. Okay, I was ready for translating C. I don't know if I'm ready for translating C++. What? What is this? Code? Code? And you shift to the left? So why did somebody think that this is a good idea? I don't get it. Like they looked at print and they said, you know what? Print? That's can you understand how many problems there are with just printing? So what if instead of printing, we shift left on this thing called code? Why can't you just print, man? This is like the JavaScript insanity that I was dealing with yesterday, but closer to things that just should not be that insane. Like in a sense, the fact that JavaScript is insane, while obviously not great, at least it's not near your kernel. It's not like at the core of your operating system and your like critical infrastructure. And so, but this is right now, I'm sure that on one of my machines, on my phone or something, there's a piece of software that is shifting left strings into into a count variable. Oh man. I can try. So I can try. I don't know. Hopefully, somebody in chat who understands and maybe even likes C++ can help us untangle some of the insanity. But yeah, well, we can try. Yeah, I get that they're trying to be fancy. It's just, I don't know. It feels out of place. Why are you doing this? There's so many other things that you could improve it in the language. Why did you do this? What is wrong with C's print or any print for that matter? In any case, yeah. Okay, let's do these Polish code owners auto merge stuff, and then I'm gonna call it a day. Maybe we can tweet about doing ray tracing in a weekend tomorrow, and then really call it a day. Okay, so what's wrong with Oh, I should do also a release of Zine, but I'm gonna do that off stream. You guys don't need to be here watching. CD, code owners, auto merge. So here's what people suggested. Okay, so here's the thing that I want to do. I want to rename this parameter to something that is in CWD because it looks like. I'm just gonna call it dir. Path to the directory containing code owners. Merge method, default merge. I would say default. Can we do rebase? The problem with rebase is that you can't always do it if there's a conflict. Yeah, I think leaving merge as the default is not a bad idea. And by the way, I think that this is a lie because right now, if I look at our source index, So this becomes dir. And let's rename also CWD to dir. That why is this called CWD? I don't get it. I kept this from the original code, but like it makes no sense. Also, I just noticed this. This print is absolutely unnecessary. Then the prints are fine. Yeah. So somebody pointed out in Discord correctly. This was Silver Squirrel, I believe, who pointed out in Discord that if the code owners file that we want to look at is the one base at the base of the PR, we might end up with funny surprises because they might choose a old, like they might be somebody that is not shouldn't be able to auto merge stuff on the repo anymore, but they still do that because what was I saying? Sorry. It's been 4 hours. Sorry. What I was saying is they might be somebody who at some point was part of the repo, but then they got kicked out, and so they could choose a old commit where they were still code owners, and here we would consider them still a code owner, and thus we would merge their PR, even though we shouldn't. So the ref needs to be something different, and the ref needs to be the default branch. So how do we get the default branch from this shit? I guess first of all, we need to take a look at get content and see what get content does. GitHub get content rest get repository content. Perfect. Owner repo path headers. Let's see. Gets the contents of the repository, specify the path in the directory path parameter. If you meet the path parameter, you will receive the contents of the repository's root directory. Media types, we don't care. If the content is a directory, no, we don't care. If the content is a symlink, no, we don't care. If the content is a submodule, no, we don't care. More. Come on. Owner, repo, path, ref, the name of the commit branch tag, default, the repository's default branch. Perfect. So we just omit this and we're good. There we go. Then we need to change the README, and we want to change also, I think, a bit of the description. So let's say code owners auto merge, check supported variables dir merge method merge. Actually, is it actually merge? I think we are not defaulting to merge. I think we are lying. Where is it? Yeah, or squash? No, or merge. That should be the default. Okay. Then readme. So this is there, this is okay. This is all okay. Let's explain the main use case even better. You want code owners to be able to auto merge PRs to files they are owners of. Let's say self merge. They are owners of. The co-owners could be external users, i.e. of a public repo, or collaborators added to the repo that has what is it? Force all stuff to come from PRs. Where is it? This stuff. Christoph IT. No. Temp test. Settings. What's the name of this stuff? Rules. Rule sets. New rule set. Yeah. Um. mm, 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 require require a pull request before merging. Yeah. Require all commits be made to a non-target branch and submitted via pull request before they can merge. Yeah. To repeat that has require a pull request before merging enabled plus require approval. No, require plus require review from code owners. The code owners could be external users of a public repo who are still, well, in any case, public repo or collaborators added to the repo that require all records managing, blah, blah, blah. This bot will check if all files in the file have a submitter as the code owner, regardless of their, regardless of whether they are a collaborator or not. And if so, the PR will be merged automatically. The bot will use as source of truth the code owner's file. The code owner's file at the latest commit of the default branch. Okay. Okay. So npm run dist and force push. Perfect. Now let's go to our test. Okay, so now we can go here. Where's the PR? Why is it not suggesting? Am I dumb? Okay, there we go. Create the PR. Okay, so it seems to not have regressed. Okay, cool. So we did this. Awesome. That was easy. That was really easy, but I did it. We did it. Okay, so thank you all. And yeah, I'm gonna announce later the idea of doing ray tracing in a weekend this weekend. So I hope you had fun. You learned something. I don't know what precisely, but hopefully you did learn something. And yeah, this is it. Let me see. Who do we raid? Who do we raid? Um, uh, 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 uh. I learned that C pointers are bullshit. Oh wait, did you post the? God damn it! Sorry. Before I leave, did you post the error somewhere? Did I miss your link? Oh yes, I did. Totally. God damn it! I am so sorry, Blurry Cat. Let me double check this now. Okay, with the code above, let's see. RocksDB open. With the code above, expected type. This found. Yeah, a pointer to only one of these guys. So you want this is only one. You fixed it with pointer cast. Okay, let's see. Um with your suggestion, pointer many null to many optional pointers, blah blah blah. Let's see. Pointer type child this. No! Why are you doing ampersand then? Oh, wait a second. Wait a second. Um let's see. And we're not trying to pass ampersand. Pointer child. Oh, you didn't repeat the declaration of R. Okay. Pointer child this cannot cast to this. Why can't it? Oh, it tells us why. Pointer sentinel 0 cannot cast into pointer sentinel unreachable. That is so. I think this is fair. This is interesting wording, but this is fair. So this is saying, yeah, you think you're gonna have a null terminator, but this is actually a type that does not guarantee the presence of a null terminator. So wait a second. Why? But why can't you do that? If you have something that guarantees a null terminator, you can always cast it to something that does not need a null terminator, does it? It's entirely expected that this needs pointer cast. It's just unsafe. Okay, understood. Okay. But in any case, the point, I guess, the good news though is that this is you got you got the right shape, and then even if you had to pointer cast, at least you're not like pointer casting, stuff that absolutely makes no sense. They shouldn't be pointer casted to one thing to the other. So that's good. Let's see the function signature in C. Char star star star. Yeah. Yeah. So yeah, I guess basically what it's asking you is to give you a. Oh no! Wait a second! No! No! In this case, I think this is not really a pointer to many things. Like many pointers to many things. I think in this case, it's a pointer to a string. That's what it wants. It wants a basically what it wants is to be for you to have a variable that points to like a variable of type string, and it wants to be able to write to it. Yeah. Exactly. Sorry, I didn't realize this until I got here, and when I got here and I saw this, I understood what this was supposed to be. And the thing is, I don't believe that you can really know what it is supposed to be until you understand like the semantics. I think there might be some symbols that they can put there to tell you what it's supposed to be, but they don't really use it um often or ever. So yeah. This is just the Roxas video wants to be able to give you a string basically. Um and he doesn't know any better way to do it than a pointer to a string. Yeah. Peak error handling, yes. Okay. Let's see. Did I miss any other comments? Oh, I missed also another message way earlier. So I've been curious about Zig and have been thinking about getting my toes wet with a node add-on with via node add-on API. Do you know if anyone in the community has dabbed in that? I'm sure there's people who have, but it's like a general. Sorry, I know that this person is probably not here anymore. But in any case, if anybody's interested, um, it's general C interop. Right, coincidentally, it's this kind of delightful stuff. So anybody who has done any of this work, like Blurry Cat, I'm gonna throw you under the bus, Blurry Cat. So go ask Blurry Cat. But anybody who has done any of this work will kind of know roughly what to do with any other CABI interoperability thing, more or less. Okay, I think this is really it for me. Let's raid. Uh, let's raid Lucem Tenebras maybe. Let me open the stream for a bit so I can see. And I can decide. Yeah. What was the question? No, don't worry. There was no question. Enjoy the raid and see you all next time.